Have joined so far. Shall I start?
So
Okay.
I guess we should wait.
Acha. Have anyone put the message in your group? And just tell them to join fast. See, there is already a break given to you for 20 minutes, right? So you should be on time in this class. Okay. Anyway, now I think I will start because 54 minutes are there. Please be punctual. Engineers must always be punctual. Right? It is the punctuality which will take you up in your life. Your graph will be in upward direction if you will be punctual enough, regular enough. So these qualities must be inculcated in yourself by you only, not by others or not by force. Okay. So I will just share the screen first. So yeah. So in our last lecture we have seen the some terms of trees and also we have seen binary tree, right? And then how to create the tree that we have seen, and in that we have followed one principle that we are going to create only binary tree. That means a node or an root node will not have more than two nodes, will not have more than two children, one left, one right, not more than two. It may have zero, one, or two, right? So and the if the root value is say 10 and you want to insert 5, that means the new node value is less, then we will insert it on the left hand side. That principle we will follow throughout our course, right? So today we will see the binary tree traversals. Already we have seen in order tree traversal, and now two more tree traversals are remaining. Those are pre-order and post-order, and then we will see how actually the tree is helpful for us for searching the data. Already we have seen one algorithm of that binary search algorithm, but it was using array. We have seen that, but the same we will have to see using tree, binary search tree, because we are going to uh, implement all those things uh, in trees only, right? Am I audible?
Yes, sir.
Yes, sir.
Okay, fine. So now I will just draw one tree here, and then we will have an examples of in order, pre-order, and post-order. Right? Suppose I am having one node, say A here, right? This A is having a node toward left and toward right. Then B is also having a node toward left and right. We can also draw the same thing. That's right. Then C is having,
So,
yeah,
so few students are waiting outside. Can you let them in?
just a minute. to stop present class. To the stop present. I think no one is still here. No one is there in the lobby. Yeah, now they are. Okay, fine. See what is happening after 5 minutes if you are joining. I can't wait continuously for 5 minutes, right? You have to join in the first 2 3 minutes. I think now no one is there in the. Okay, I will now present my screen. Yeah. Now is someone waiting outside?
No,
Yeah,
sir.
all are in. Okay, fine. So I will start my lecture. The screen is visible, na? The screen is visible.
Yeah,
Yes, sir,
sir, it's
yeah.
Yeah.
visible.
Yes, yes.
Okay. So I will take the same example which I have taken on that day for in order. So after then I am having another node say G, and then there are two nodes for G, R and O, right? So suppose this is our example of tree, right? And I will take one more example toward this end with values inserted, right? So we will see with value and with labels. So here suppose 10 is there. So here if I want to go, the value should be less than 10. So if I am taking value 7 here, here again the value should be less than 7. So it will be 5. Here the value should be greater than 7 but less than 10. So that I can take here as say 9. Here the value should be greater than 7 but less than 9. So I will take value here 8. Right? Now if you come here, suppose I am taking value 15. Here the value should be less than 15, so I am taking say 14. Here the value should be greater than 15, so I am taking say 20. Here the value should be less than 20, so I am taking 18 here, and here it should be greater than 20, so I am taking 22 here, right? So just both three are similar tree. Only thing is that here we are using labels and here we are using values. So once we will solve with labels and then we will go with values so that you will come to know what exactly is happening, right? So just to revise for in order, right? In order, you know that what is happening? Operands, then operator, and then again operand, right? For example, you can say A plus B, for example, right? And if you talk about pre-order, then it is operator, right? And operand, that is plus AB. And if it is post-order, then it is uh, just like postfix, operand, operand, and operator. It will be say AB plus, right? I think this all of you know. This is an infix, this is an prefix, and this is an postfix. So what happens in order? First, the operand on the left hand side. You can say we have seen that the first operand is the left node. The second operand is the right node, and the operator is the parent node. Right. This conventions we have seen in our previous class. So if we talk about in order traversal, right? What is happening? First, we are having left node, then operator, and then right node. Means left node, parent node, right node. So if you are here, you will start from here. If you are here, then you will first visit left node. So you will come to the V then, right? You will come to V. Then B is again having left node. So you will come to D, right? And D is not having any more node here, you can see, right? So this is the left node which should be printed first. So I will say D. Then what is the next? The parent node should be printed. Which one is the parent of D? B is the parent of D. So we will go to B. And then we have to print right node. So when we come to E, but E is having left node. So first we will print H and then we will go to parent back E. So E. Now E is not having any right node, so we will go back to B, right? And then we will go back to A. So now we will print A. And then we will come to the right hand side C, right? But C is having left node. F. F is not having any node, so I will write F here, right? Then you will go back to C, so you will write C here. C is having right node G, but G having left node. So we will go to first I and then G and then G, right? This already we have seen in our previous lecture, right? And if you consider the same with values, then if you see D is replaced by say 5, right? Then B is replaced by say 7, then E is replaced by 9, whether it is correct? Sorry, H is replaced by 8. Sorry, H is there. H is replaced by 8. Is replaced by 9. Then A is replaced by 10. Then C is replaced by 15. Then, sorry, excuse me. F is replaced by 14. F is replaced by 14. Then 15. Then 18, 20 and 20. Right? So, any doubt in this? This we have seen in our last lecture. Now, we will talk about our pre-order. What pre-order says that first you have to use operator and then operand. So first operator means what? First we have to look for parent node, right? And then left node and then right node. So first we will print the parent node, right? So we will start from once again this tree A. First is the parent node, so I will print A, right? Then I have to go to left. So I will come to B, right? And I will print B first, right? And then B's left node I have to print. So I will come to D. Now D is not having any more node, but it is a left node of B, right? So what is the right node of B? The right node of B is E, but it is having again left node, right? So after B we will visit E, right? And then for E, we are having only one node, that is H. We don't have any right node. So the left portion is now over. What we have done in left portion, we have started with printing the root node, that is the parent node, and then we are visiting the left portion. So when we visit the left portion, we will print this left portion and again check whether it is having left portion or not. If it is having left portion, we will print that and again we will go to the left portion of that. But here D is not having any left portion, so we will go to parent node and we will come to the right hand side. So again we will print the right hand side node and we will go to the left hand side. Now this H is printed, there is no more node, so we will come back to E and we will go back to the right node of E. But there is no right node of E, so we will go back to A. Now from A we will go to C, right? So we will print C first and then we will visit left. What is left? F is left. Now F is not having any more nodes, so we will come back to C and go to G. Because we have to print parent node first, so we will print parent node first, G, and then I will print left node, that is I, and right node, that is G. So what is the sequence? A, B, D, E, H, C, F, G, I, G. This is the sequence. Got it? Yes, no?
Yeah, sir.
Yes, sir.
Yeah, yeah. I will repeat this with the help of this label, these values. So again, I will start in pre-order. What we have to do, we have to print parent node first, then left node, and then right node, and it is being done recursion. If parent node is having left node, if then left node will be printed. If left node is having again left node, then that left node will be printed, and so on and so forth. It will be going in a recursive manner. So we'll start with a 10. So I will print 10 first here, right? Then I will start with the left portion. So I will visit 7, right? I will go to 7. Then the 7 is also having a left node. So I will go to 5, right? Then I will go towards the right hand side, that is 9, and then I will go to the left hand side, that is 8. No right hand. So again I will go to 10 now. From here you will go back here, from here you go back, from here you go back here. So from 10 now you will come to right hand side, that is 15. Then you will go to the left hand side, that is 14. No more further nodes. So come back to parent. Already we have visited parent. We go to right node. Right node is 20, and the left node is 18, and the right node is 20. So this is how the pre-order will exist. Now, what you think that why the pre-order is useful, or why the in-order is useful, or why will be the post-order will be useful? That questions will come to our right. So for that purpose, what I will do, I will just go to next screen, and now what I will do, suppose I am now doing like this. Suppose instead of value, I am writing plus here, right? Instead of value, I am writing plus here. Then I am writing star here. Okay. Then I am writing say 5, say 9. Okay. Then here I am writing say slash, that is divide, right? Coming to this, I am say 10 here, say 2. For example, right? It is like this. So if we talk about in order, right? If we talk about in order, what will happen here? We have to first print the left node, then parent node, and then right node. So we'll start with here. We have to go to left node. Again, this is having left node. So I will print 5. Then I will come back to this. I want to print parent node. So I will print star. Then I will go to right node, right? And then I will go to the middle parent node of the parent node of 9. So plus, then I will come to the right node, and to the left of that 10 slash 2, right? So this is the expression. This is called as expression, but it is in order expression, right? So what will be the answer here? 5 into 9, that is 45, plus 10 by 2, that is 5, is equal to 50 is the answer, right? So if the parent nodes or intermediate nodes, parent or intermediate nodes are replaced by actual operators, then the tree becomes expression. The tree becomes an expression. But this becomes expression. Getting? So what we are doing, we are, if we want to solve the problem, solve the expression, then what actually any compiler does, what any compiler does, whatever equation or expression is written by you, it creates a tree for that expression. It creates a tree for that expression, and then it evaluates it. So once the expression is ready, then what we have to do? We have to evaluate. So If we consider the same 5 into 9, I will write 45. Value of the node here is 45. I will go up and I will do this 10 by 2. The value at this node is 5. And here operator is plus. So 45 into 5. 45 plus 5. Here the value will be 50. Right? So you get, if you traversal, do the traversal in order, then and go on solving the problem, you will get the answer. So that is an application of in order. Similarly, the applications are there for pre and post order. Normally, I think you know that what compiler does, whatever expression is given by the user, it converts into postfix expression and then it evaluates. Because while it is evaluating postfix expression, the algorithm is very simple that we have seen in our previous unit. That simply you have to pop the two operands and perform the operation, store back the result. Right? Pop the two operands, perform operation according to the operator and store back the result. This was the simple algorithm which is there for evaluating a postfix expression. So that we are doing. So in case of pre-order, if we write the same for pre-order, same example, right? So in case of pre-order, what we have to write? We have to write plus parent node, then left node, and then right node. So if we start from this plus, I will write first, plus is parent node, right? So parent. This plus is having 45 star as left node, right? So I will write left node. This star is having a leaf node, that is left node 5, and the star is having right node, that is 9. Okay. Then you go back to this and you come back to the right hand side. So this, again, this slash is a parent node, right? And this 10 and 2 are leaf nodes, so 10 and 2. So this is your prefix expression, right? So by traversing in the pre-order, you are getting prefix expression, right? By traversing in order, you get infix expression. So same is the case for post order. Can anyone tell me? I will just repeat the same thing again. First plus plus star and 5 10. So actually here the value should be greater than 10. If I'm so that was my mistake. I should not write 20 here. I should write 20 actually. If it is, I should write 20 here, right? Because what is our principle? That the right hand value should be always greater than the left hand. So I will write 20. Now if I go for post order, right? What is there in post order? First left node, then right node, and then parent node, right? That is what we mean by post order. So we'll start with this. This is parent node. So we are not supposed to print parent node first. We are supposed to print left node first. So we are going to left portion. But this is again a parent node, right? This is intermediate node. It is again a parent because it is having, it's not a leaf node. It is having a left node. So we will visit the 5. So we will print the left node. Then we will go to the right node, right? Right node, that is 9. And then we will print the parent node, that is star. Okay. So 5, 9 star. Then we will go to the right hand side of this parent node. This is the parent node which is not yet printed because it is having right node also. So when we visit this slash, again this is a intermediate node and not a leaf node. So it is again a parent node. It is having the left node, that is 10, right node, that is 20, and then parent node is slash, and then we will come back to the root node, that is plus. So this is, I think, postfix expression, right? Got this? So if we doing traversing, in different way, we get different expressions, right? And one more thing, yesterday I told you that if the intermediate nodes are data nodes, and if you do the traversal in order, then what you get, ascending order series you get, right? That we have seen in our previous lecture. So any doubt in this?
No, sir.
Yes. Okay, so what I will do, I will give one example to you, and you have to write the uh, post order equation or post order uh, nodes visited in the post order form. Sorry. So suppose this is A, this is B, C, D, F, G. Suppose this is like the tree is like this. Okay, it is a binary tree. Now just write down the post order traversals. The path in which the node will be visited in post order traversal. What will be the path? One thing which you have to keep in mind is that left node, right node, and parent node. Just write down now. All of it. Uh, DED, DFC, okay. Okay, one student has given this answer. DED, DFCA. Display group. Can anyone tell me whether this is correct or not? Yes, Tiwari Shivam from B division, roll number 20. Yes, Tiwari Shivam. Yadav from BDE. Yes. Yes. What about A? Yadav Amit, you forget A. A should be written at the end. Okay, I'm assuming that you might have forget A. Yes, I'm writing A. See, one student has given answer BED, BFCA, other has given BDE, BGFA. Yes, anyone? BAE. Okay, other one is saying BAE. So instead of here, you are saying BAE. Then where the D will be?
No, sir. It's like BADE.
BADE, right? BADECDF, right?
Yes, sir.
Okay, okay. So, this will be. Yes, others, please, you have to respond. Then only I will come to know whether you have understood it or not. Yes, where BDE, EFCA. So now we will start solving this. What is our formula? Our formula is that we have to first print left node, then the right node of that parent, and print we have to parent node. So here we will go to the first node. This is the say parent node right now. We are going to the left of this because we have to print left node first. So then this B is not having any child node. So B is a leaf node. So I will print B here, right? Then I have to print right node. So I will go back here and I will go to, I have not printed A yet because I have to go to the right node. But this right node is again a parent node of some other child. So we have to visit to left node of this, right? So I am going to left node, but this is again an intermediate node. So I have to go to left, but left is not there. So I will go to right, right? So this is the leaf node. So I will write E here, right? And then I will go up, I will write D here, right? Because this path is over. Now I will go to here, but this is having right node, so I won't print C. I will come back to F, but F is again an intermediate node, so I will go to left portion, that is G, and then I will go back to F, then I will go back to C, then I will go back to A. So it is BED GFCA. I think Drumil has given the correct answer, right? Others, how you can write A first here? Because see, A is the parent node, but it is having right node also. And what is our concept? We have to print first left node, then right node, and then parent node. So when we are going to left portion, we will print B, but we should not print A here. Rather, we should go to the right portion of this because here Rn is there. So you should go to right. But right node is not a leaf node. It is in turn a parent node. So again, we have to follow the same concept, recursive call. So again, we will do the left, right, and parent. So we go to the left, but this is again not a leaf node. It is a parent node, but it is not having left node. It is having only right node. So we will print right node, that is E we will print, and then we will go to up, right? So already we have seen left and right of this node. So this node is remaining. So we will print D. Then we will go to C, but we have not yet seen the right portion of this. So we won't print C. We will go to the right portion F. F is again an intermediate node having left node. So we will write G here. And then we will go up. F is not having any right node. So we will write uh, the parent node, that is F here. Again, we have seen the now left and right of C. So we will print C. And then we will go back here. Again, we have seen all the left and right of A. So we will write A here. So the sequence will be B, E, D, D, F, C, A. Any doubt in this? Let us have one more example to clear the doubts. A, A, X. Suppose this is the tree. Now try to find out post order traversal. In that you have to again keep in mind that you will first visit left node, then right node, and then parent node. In in between, if your left node is the parent node, you have to again go with left, right, parent. Again, the recursive you will go on. So now just try to solve this. All students must do this exercise. By simply seeing, you cannot understood the concept of the tree, because here the recursion is there. So all the problems of recursions are to be solved by individual. Then and then only the concept will be clear. It is not like a stack or linked list where you can have some kind of imagination and you can do the problems. But in case of tree, you have to do by yourself because recursion is there. Okay? So for clearing the concept of recursion, you should solve by your own. Yes, any answer? Uh, yeah, E, F, D, D, B, I, E, F, D. Someone has given answer. E, F, D, then E, I. JHIJHEA. This is the answer given by one student. PFCPIJH. Other student has also given the same answer, wheel, and the other one is uh, EFDCPIHHGA. Chakravarti has also given the same answer, I think. So now all the students are giving same answer. So let us check whether the answer is correct or not. So we will start with the parent node. This is parent node. So we will go to the left node first. Again, this B is a parent node, intermediate. So again, we will go to the left node. Again, this is a parent node. So we will go to the left, but there is no left. So we will go to the right hand side of this. Again, this is a parent node. So we will go to the left. So we have reached the left portion of the tree. Leftmost leaf node, that is E. So I will write E. Then I will go back to the parent and go to the right portion. So right portion F is a leaf node, so I will write F. Now of D we have seen both left and right, so we can write D here because we have seen the left portion of D and we have seen the right portion of D. Now we'll go back to the C. Already there is no left and we have seen the right, so I will write here C. Now again I will go back up B. There is no right. All the left portion of B we have seen. So now we will write B. Again we will go here. So now we have seen all the entire left portion of A. So we will now go to the right portion of A. That is G. G is parent node. So we will go to the left portion of that. Again this is parent. So we will go to the left portion of that. So this is leaf node, left portion. So I will write I. I will go to the upside. So we have seen the left portion of H. Now we will see the right portion of H. J is a leaf node. So directly I will write J. And I will go back up. Now here we have seen the left and right of this parent node. So I can write parent node here. Again I will go up G. We have seen the left portion of G. Now we are going to see the right portion of G. But there is no right portion. So we will write G here. Okay. And then we will come up. So all the entire right portion we have seen now. So what is remaining? A is remaining. So what is the answer? E, F, D, C, B, I, J, H, C, A. So this is the correct answer given by three students. Three students have given this answer. So I think now all of you are knowing the concept of the tree. Yes?
Yes, sir.
Okay. So in this way we are going to traverse the tree in order, pre-order, or post-order. Why these three are there? It depends on the compiler which strategy it is adopting. Right? Some compilers may work on prefix, some compilers may work on infix, some compilers may work on postfix. Right? It depends on the choice of the compiler programmer, what he wants to do, with which he is comfortable according to his application. So all the three traversal modes are possible. So that we have to do, right? So we will just see the program, how the program is written for this one. We will just go to Python. Uh, does anyone is there who has not execute any program in Python? Is there any student who has not done anything in Python so far? Yes, either in A division or B division. Is someone is still yet to write a program in Python and to test the Python code? Yes, roll number 23, Parab, coming. Roll number 24, Parmar. Have you written code in Python?
No, sir, not yet.
Why? What is the problem
सर
you are
एक्चुअली में
facing?
पीसी बंद है, उसका हार्ड ड्राइव क्रैश हो गया तो वो कुछ चालू ही नहीं हो रहा करने के
कब
लिए।
से बंद है?
सर 2 दिन हो गया।
तो अपने को तो डाटा स्ट्रक्चर चालू करने को तो 1 महीने के ऊपर हो गया ना, 1.5 महीना हो गया।
हाँ सर, वैसे पहले के मैंने किए ट्राई।
ये वही मैं पूछ रहा हूँ, कितने मैंने पाइथन से आप रूबरू हुए या नहीं हुए, ऐसा पूछ
यस
रहा
सर।
हूँ। ओके, yes, roll number 25, Pedinti. What is the pronunciation of your surname?
Sir, it is Pedinti.
Pedinti. Okay, fine. So you are familiar with Python now?
Yes, sir.
Okay. Roll number 37, Tripathi. Have you written some program in
Yes, sir.
Python? Yes. Roll number 43, Yadav. Have you written some program in Python? Your voice is not audible, Yadav. Write in chat box, yes, no, whatever you want to say. Okay, fine. In B division, roll number 7, Saad Khan. Have you perform any program in Python? Saad Khan? Yes. Saad Khan. Sir, I mark you absent. You are not responding. Okay, I think I am wasting my time. Okay, fine. So what I will do now, I will just take you to the code in which we are going to display the tree in the in order, pre order, and post order. The code is very simple because here we are taking the help of recursion, right? So if we consider this highlighted portion right here, the code is very simple. Pre-order. This is the function for pre-order, right? So in pre-order, what is the main thing which we want to print first? We want to print the parent node first, right? So we will print, we will visit the parent node and print it. So here we are printing the parent node. Now this is the just syntax. We are converting the data into the string format. If you see, are you able to see this line? Right? What I have done
Yes.
here, what I have done here, whenever I want to print something, if I am printing, if suppose A is 10, if I write print A, it will print. But if I want to write it with something along with this, say print value of A is, and then I have to write, then I will convert this to string A. Like this, I can write, right? So you have to convert the integer to string, and that's why that string function is given there. That's all. So if there is any problem, you can directly go to the net and you can find out the syntax of all those things, right? So those are self-explanatory. So in pre-order, we need to print the data of the parent node, and then we need to move to the left and then to the right. So if self dot left is not null, that means if this parent node, if this parent node is not a leaf node, right? It is just like this. Suppose for example, if this is my 10, this is my 5. So in pre-order, we will print 10 first, and then we will visit to the left node. Now this parent node is having left node. So if self dot left, if it exists, the left node of this parent which we have printed, we have printed the value 10, and it is having left node. So if it is existing left node, then we will call the left node function. Okay? That's what we have said. If there is a left node is exist, then we will call the same function with self dot left, the same function. And if the right node exists, we will call the same function again with the help of self dot right. So that's all. So this is the power of recursion, that by writing a very simple code, you are able to visit any complicated tree of any size, right? Only thing is that what you have to keep in mind, that you have to print the data first, because parent node value we have to print, and then we should go to the left, and then we should go to the right. That is what is our case. Because in pre-order, what we do, parent node, then left node, and then right node. So the same thing we have done here. Okay. Now, in case of post order, what we are doing, we are going to first left, then we are going to right, and then we are going to print that. So, display tree post order function will this will call left first, then right, And if every left and right of that node is over, then it will print the value of that node. Right? So that is how the three functions are written. Any doubt in this? So here this is the code. Already I think I've explained you the insert code, right? I've explained you the insert code. Yes or no?
Yes, sir.
Yeah. Because there only you have to use the policy that the left hand side should be less than the parent node and right hand side should be greater than the parent node. That's the policy you should adopt always while creating the tree. Okay. Now, once the tree is created, right? How we will create the tree? First, we will create a node which is called as root node. This we will create a node temp, right? Here is the class of node in which the node is created and the left and right are none for that node. So root node is created and then with the help of this root node, we are going to add the elements in the tree with the help of this insert function. So what I have done, I have inserted 7, 15, 5, 9, 8, 14, 19, 18, 20. Right? So how you will check whether the tree is correctly created or not? By seeing the in order tree. Because in order tree you will get the number in ascending order. So if we run this program, you will see that in order tree the numbers are in ascending order 5, 7, 8, 9, 10, 14, 15, 18, 19, 20, like this. Okay, 10, 7, 5. This is pre-order and this is post-order. Right? So you can create any tree and check whether it has been created correctly or not with the help of in order function. Right? But in reality, what will happen when I run this program? If you want to evaluate the expression, you want to evaluate the expression, then in that case, the intermediate nodes will not have any value. Right? Intermediate nodes don't have any value. They will contain operators, and then we won't be able to compare that whatever policy we are adopting right now. That if the every node is having data, but in that case, in case of expression tree, every node won't have data. Some nodes will have data and some nodes will have operators. Can you tell me the nodes which are having operators are leaf node or intermediate node?
Intermediate.
And the nodes which are having data, whether they are leaf node or they are intermediate node,
Leaf nodes.
the nodes which are having data will be always leaf nodes, right? Because they are the operands on which the operation is to be performed, right? So that thing you have to keep in mind. So how to construct an expression tree, right? First, what we will do, we will just see once the our tree are created, we will see that how to find the minimum element of the tree. Can anyone tell me from here? Yes. Suppose I am taking this. What is the minimum element in this tree? Okay, I will go here. Yeah, yeah. This tree. This tree. What is the minimum element? Can anyone tell me? In this tree, यहाँ पर minimum element कौन सा है? Mean, mean is what? In
5.
this tree,
5.
5 and max
22.
22. Can you tell me what is the property of this 5 and 22?
Leftmost and rightmost.
Yes, this is the leftmost node, right? And this is the rightmost node. So if you want to find minimum, then what you should do, you have to visit the leftmost node of the root node. So once you visit the left node, then the last leaf node of the left part is the minimum element. And the part on the right hand side, right? The right hand side node is the last right hand side node of the entire tree will have the maximum value. So what you have to do, simply you have to traverse. You will visit first parent node. If it is having leaf node, you will go to the leaf node. If it is having leaf node, you will go to the leaf node. If it is having leaf node, you will go to the leaf node. So you will continuously going on to the left hand side until it doesn't have any more left node. So in this case here, the phi is not having any left node. So phi is our node. And if you see about right node, we are going to the right hand side, 15 is there, 15 is having right hand side, 20 is there, 20 is having right side, 22 is there, 22 is not having any right hand side. So 22 is the maximum number of the tree. So how to write the code for that? The code is very simple. In suppose I am written the function get min and I will pass the root node there. Simply you have to do traversing, right? This is already we are aware of this kind of codes of traversing. That we are going to the left hand side. While current dot left is not none, current is equal to current dot left. So we are going to the left hand side. And when the current dot left is none, you will come out of this loop and whatever the current node is there, the data of that current node you can pass on to calling function. Similarly, in max, instead of left, you are going to the right hand side. That's all. So by this function, you will come to know the mean and max value of the tree. Definitely, one should ensure the tree is created according to that principle, which is our main assumption. All the left-hand side values are smaller than its right-hand side counterpart. That principle, if you are following, then and then only this get mean get match function is giving the correct value. Right? So today we will stop here, and in the next lecture we will see how the expression trees are created and how to evaluate those expressions. Any doubts so far? Please feel free to
No,
ask
sir.
any doubt. All the students, I think why students are leaving
No,
the
sir.
class. Uh, Earlier it was 38 figure here, now it is 34 figure. So please don't leave the class in between. If you are going to leave the class in between, you will be marked as absent. You know very well that. So please